Okay, so now let's use what we learned in the last podcast about completing the square and see if we can turn things from standard form, that's this form here, into vertex form, which is this guy, y equals to ax minus p squared plus q. Because if you remember, this form tells us a whole heck of a lot more. Sure, this gives us the y-intercept, that's nice, but this gives us the vertex, which allows us to figure out the range better, allows us to figure out the maximum or minimum value. It allows us to figure out the axis of symmetry and just all kinds of wonderful things more. So it's very valuable to be able to put this back in this form. But how do you do it? Well, we do it by completing the square. Now, remember what we did last time in terms of completing the square. We ended up looking at this guy right here and we said, oh, that's 8, that's simple. We take half of that and becomes positive 4, and this becomes our magic number. Then we said, okay, from here we would square it. So 4 squared, which is 16, and we'd put the 16, we have a problem. That's not 16 anymore. That's a 4. So what do? This guy is not cooperating very well. Well, you can't just cross him out like that and say he doesn't exist. No, the 4 is there for a reason. That's our intercept. Well, what do? Well, simple. Do you ever heard the expression, like you must have heard this once before from your parents when they're angry at you? And they said, well, if you're not going to get along with us and you're not going to cooperate, you can get out. Well, same kind of idea. Hopefully it's not that traumatic. But anyways, same kind of idea. What's not cooperating? The thing that's not cooperating is the plus 4. So let's throw it out. Throwing it outside, yep, the bracket. Check this out. Look at this. This is now plus 4, way out here. So now we can go and do exactly what I was doing earlier and say, okay, half of this is positive 4. There's the magic number. Square it. That becomes plus 16. But I can't just go out and say, okay, here's you go. Here's your plus 16. Everything's fine. I can't just add 16 to something. I got to get rid of it. I can't just add 16 arbitrarily in here without, accounting for it somewhere else. So I'll tell you what, I'm going to add 16 here, but I'm going to subtract the 16 out here. Now you're probably saying, well, how can you do that? Is that allowed? Well, certainly it's allowed, because look at this. All I'm doing is adding 16 here, subtracting 16 here, add 16, subtract 16. I'm actually adding nothing. 16 and minus 16 cancel out. I'm just putting it in there temporarily so I can complete the square. And look what happens when I do complete the square on this. Being that this is the magic number, this becomes x plus 4. There's your magic number that comes down into here. Don't forget, this is completing this square. So remember, that's squared. But look what I have out here. 4 minus 16, which works out to be minus 12. There you go. There it is in vertex form. Isn't that awesome? It's so cool. So the vertex here then would be minus 4, minus 12. But I know what you're saying. You got to be able to prove that to me. I don't believe you. Well, wait a second. Okay, let's write these things out. Write out the two equations here for a second. Y equals to x plus 4 squared minus 12. And write out the original. The original here was y equals to x squared plus 8x plus 4. Now let me show you a couple things. The first thing I want to show you is this. Notice that the a value here is 1 and this a value here is 1. So that's okay. They're both opening up and they're opening up normally. But how can you prove this on a calculator? Or how can you prove this on a graph? Well, I just gave it away. Use the calculator. How are you going to do it? You're going to put both equations in. The original, which was x squared plus 8x plus 4. So x squared plus 8x plus 4, okay? And graph it to give you this. And now you're going to put in the one that we found, which was x plus 4 squared minus 12. X plus 4 squared, okay, bracket x plus 4 bracket squared minus 12. And let's see if they give you the exact same thing. Now think about this. This guy is originally now in blue, right here. He's in blue. And this guy is going to be in red. So what's going to happen is you're going to have an original graph here. Oh, I should have done it in blue. Oops. Here we go. You're going to have an original graph here in blue, and then when this guy, the calculator, decides to draw it, if it's exactly the same, it should go right over top and replace this blue line with a beautiful red line. Let's see if that happens. Now, let me get rid of this, and let's see if that's exactly what we get. I'm so stoked to see this. Ready? Graph. And sure enough, the blue line was replaced by the red. Did you see that? It was so gorgeous. So in fact, we have exactly the same graph. Both of these equations mean exactly the same thing. One is in vertex form, one is in standard form. And that's how you do these kinds of questions. So I've got another question here to practice with. That's this one right here. Why don't you stop the podcast right now? See if you can complete the square using this other thing. Okay, I'm going to stop the podcast. I'm going to clean up this area a little bit, and then we'll come back right after this. But you try it first. Okay, how did it go? You ready? Let's you and I do this together. Here we go. So, first things first. Remember, this is the house. This is the guy that doesn't cooperate, so you kick him out. X squared minus 6x. You're out of the house, but you're still there. Okay, now, half of this gives you minus 3, which is, of course, magic number. Squared, negative 3 squared is positive 9. If you're going to add 9 here, you have to subtract 9 there. Perfect. So this is now, because of the magic number, x minus 3, a perfect square, right? Okay. 8 minus 9 is minus 1. There it is in vertex form. That should be it. Okay, so let's see if we can do this on our calculators. Let's put the 2 in there to check and make sure we get the same thing. So x squared minus 6x plus 8, that's the first one. Okay, so we'll clear the last one that we had in here. And up, there it goes. So again, x squared minus 6x plus 8. So x squared minus 6x plus 8, and the other one was x minus 3 squared minus 1. X minus 3 squared, bracket, x minus 3 bracket squared, okay, minus 1. See if those are the same. Double check. Yes and yes. Okay, let's graph it. Let's see if we get it. There it is in blue, and there it is in red, right over top. Okay, and it's really pretty. It's exactly the same thing. So these two equations, you can always check your answer by putting in the original and putting in your new factored one. If one's over top of the other, they're exactly the same, so you know you've done it right.